going to go back over these just to show that we drew in all of our different features. Y'all help me remember, for a median in this triangle, what is it we are looking for if we want to figure out what the median is? It goes from a vertex to the
middle of the opposite
side. So look, okay, here's a middle because I have 2 tick marks on each side. Here's a middle. So is my median going to my point F that's in the middle or to my point D that's in the middle? This is a middle. This is a middle. But which one is the median?
It's the opposite middle. It's the opposite.
It has to go, it's not the highlighted in yellow because that's not going to the middle. That one is the perpendicular bisector. But the median has to go from the vertex. So this one was the median because it had to go from a vertex to the middle. Okay, so as you have labeled these things, you're also going to have to be able to, on a picture, kind of just take a bunch of markings and determine only which one you're looking for. So like when you're looking for an altitude, what's the thing you're going to look for in your picture?
That it's not in the middle and it's in the height. So it's like.
But there's one mark that you have to look for because the height will come straight down and make what kind of angle? The right angle. But see, look, I have 2 right angles. How do I know which one's my height?
Because only one of them comes down from the middle.
And only one of them is coming from a vertex. All right. So yeah, it has to come from the vertex to the opposite side and make a right angle. And then what are we going to look for when we're looking for an angle bisector? What markings?
The middle, the like little marks there.
Yeah, the little rainbow tick mark things. So this is the one I know because of the 2 equal sides here, that's cut in half. So I'm looking for the markings to tell me which one's which. Okay, now on the theorems that you just glued in, let's go to the bottom of that page first. Let's remember what the words of central tendency are for these triangles. That's kind of the term that we use. So perpendicular bisectors, those words got cut off. You might have to fill that back in. Perpendicular bisectors, all 3 meet and make a what? What's that word?
Circumcenter.
Okay, so highlight with me, please. Perpendicular bisectors make a circumcenter, and that is that point. Does the circumcenter always have to be inside the triangle?
No, it does not have to be. It just has to be in the circumscribed around it.
Mm-hmm. So the circumcenter comes from, and I do want you to add this on here too, comes from that circumscribed circle. It's the center. So if this is an obtuse triangle, then the circumcenter can be outside the triangle. If it's an acute triangle, it'll be inside. If it's a right triangle, it should be right on the edge. Okay, angle bisectors created an in-center, so y'all highlight the point with me and the word in-center. You got a highlighter? Highlight the point, highlight the in-center. In-center also comes from the inscribed circle. So where does an inscribed circle go? Inside, touching these 3 sides of the triangle. Okay, so the in-center, will it always be inside or will there sometimes be outside or on the triangle?
It's always inside.
Always.
Because it's in the inscribed.
Yes.
In
the inscribed circle, so that means it's always going to be inside. All right. And then again from yesterday, let's remember the centroid is the word where medians meet. Median, centroid. Today we're going to learn a special theorem about this. There's no circle there, but there is a relationship. And then altitudes, highlight the point where they cross, and that is your orthocenter.
Because you get high at the orthodontist.
Yes, that's the way I remember it. So I'm going to also share with you real quick how I remember what goes with what. For medians and centroid, I think of food. I think of mac and cheese. Those are 2 little bitty M and C
mac
words.
And cheese water.
Mac and cheese morphine.
That's why you smell noodles. Mac and cheese, median, centroid. That's how I remember those go together. Quick little story to share. Did I share this yesterday? Angle bisector in-center.
It's like whenever you put your
icing.
dog's pills.
Your mom made you homemade icing?
Yes, homemade icing on a graham cracker, sliced bananas, and so bananas and icing. Apples and dip it in the icing. So apples, bananas, and icing. That's how I remember that one.
It's like whenever you give your dog a pill, but it's coated in peanut butter so he can't tell.
Tell.
Well, I would have liked any of those things. She didn't have to code them for me. Okay, then a perpendicular bisector, those are the three longest words. Perpendicular, bisector, circumcenter, they go together. You never know when I might throw a quick little quiz out at you as to what matches what. So you need to know what they go with.
Are there gonna be drawings?
No, I'm just saying, perpendicular bisector, peanut butter crackers, I know it's the circumcenter. Mac and cheese, two short words, median, centroid, you need to know which ones go with what. Okay? All right, now let's look at the top of that page, that's your theorems. So highlight with me. Where's your purple pen?
Right here.
It's right there.
Okay, you wanna highlight on there? So you
Can't highlight on purple.
I think-
Gold.
So highlight perpendicular bisector. The perpendicular bisector creates a circumcenter that comes from a circumscribed circle. So make your circumscribed circle around the triangle. This theorem states that that circumcenter, point P, is equal distances from the vertex points of the triangle. So P to B, highlight, P to Z, highlight, P to A, highlight. Those are all equal distances. It's not as easy to see why they're equal when you're putting it in the triangle, but when you put the circle around it, can you see why all three of these are the same length? What are they in the circle? Well, that's coming from the center.
They're on the edges of the circle. So they're the radius.
That's the word I was looking for. Thank you. So they are all radii. They are all a radius of the same circle, which means they're going to be the same length. Okay. So for instance, on your assignment tonight, you just have a triangle that looks like this, and it says PB is 12. See, I've got you thinking through. And then PA would be how long?
In eternity.
PB is 12.
Oh.
PA would be
The same.
12, the same, okay? Or PC is X plus 7,
Do the next one.
and PB is 12.
X is 5.
So you would make your little equation and solve, all right? Okay, next one, highlight angle bisector. Next theorem, angle bisector. And then this is inscribed circle, so you'll draw your circle inscribed in your triangle.
You should make an entire children's book
How?
of these characters.
Angle bisectors create what point? What's the name of that point again?
The center.
In center.
Yes.
That one. End center. An end center, by the theorem, says that it is equal distance to the edges, not the vertices this time. That's too long, that's even longer. But this time from the end center, it's equal distance to the edges. So distance from here to here, from here to here, from here to here, those are the same. And again, because it's a circle, those are the radius lengths of your circle, so they are equal. All right.
Paleo.
The relationship that medians cause are not anything to do with the circle. The relationships are, you have each median is cut into thirds. There are two parts. There's a 2/3 part and a 1/3 part. So y'all look carefully up here at your triangle that's on this section. Just highlight the circumcenter, the centroid real quick. Okay, that centroid sits 2/3 the distance from the vertex. So look at segment DJ. Okay, from D to D to the centroid, D to C is 2/3 of that whole length.
So
then C to
CJ
J would be
1/3 of it.
1/3. So basically it's splitting it into 1, 2, 3 equal parts. We just have twice as long on this side as we do this side. Okay, so I want to elaborate on this and do a problem with that.
Oh, and CJ. Wait, no.
Please draw
And DJ.
this example in your journal. Randy, I know it's a lot of drawing, I'm sorry.
HJ.
I'm no artist.
Draw this example in your journals, please, guys.
Drawing this example.
Because these are gonna be medians. I'm gonna show you the relationships of the pieces that are created by the medians. So draw a triangle ACE, put 3 medians in your triangle. So medians, what am I looking for? What's gonna be markings right here?
Half.
It's cut in half, so they have tick marks. So as you draw in CG, add your tick marks. As you draw in EB, add your tick marks, because this will show us that these are medians. And then we do want to go ahead and add AD and your tick marks. Okay, next to your picture, we're going to classify that these are 3 medians. Medians make a, what's the word? Mac and cheese.
Centroid.
Medians make a centroid. The centroid theorem is that your point F, the centroid, lies 2/3 from the distance from each of those vertex points. Okay? So here's our 2 problems, and we'll figure out the lengths inside that triangle. DA is 15. Okay? Here's DA. DA, here's D, here's A, is split into how many parts by the theorem?
2/3.
Thirds. So here's one part, here's another part. This part, the 1/3 of it goes to F. From F up to A is the 2/3 part. So it's 15 units long split into thirds.
So it lies 2/3 from each vertex.
Yes.
Okay.
Okay, so 15 split into
So
thirds,
that'd
Holly.
be 5.
15 split into thirds, 15 divided by 3.
That'd be so much better with scissors.
Okay, so I'm kind of drawing AD over here because I want you to see it. So basically, from F to D is 1/3. From F to A is 2/3. And then how long is it from F to A?
2/3.
10, because 2 of those 5s makes 10. So when you have the full length and divide by 3, the short side is going to be from the centroid to the side of the triangle. The longer side, which is going to be double in length, is from the centroid to the vertex. Make sense? Let's try this next one and see. EB is 21 units long. So Kyle, how long is it from B to the center, B to F?
7.
Yes, because you divided 23 by 3. And then how long, Kyle, from E to F?
14.
And so even though we're talking about fractions and thirds, once you look at the picture, if you can just get the short length, then the long length is double of that.
Wait, why did we divide by 3?
It's the theorem. So the theorem that you highlighted on your purple, yeah, it's just in medians, that's always what's happening. You have a 2/3 the distance from the vertex point. So you've got a 1/3 part and you've got a 2/3 part. You got a 1/3 part and a 2/3 part. So let's say that C to F is 18. How far is it from C,
27.
G to F?
Oh, 9.
Why?
Because 18 divided by 2 is 9.
Because this is on the 2/3 part, and I can cut it in half and know that that is this length. So then how long is CG?
27.
Because you're adding those full lengths together, the 19, the 18 and the 9. All right, and that's actually just the end of your notes. We're gonna do the assignment. I'm gonna kind of talk you through some of the assignments because there's so many little ins and outs parts. But other than that, you're through with notes, so thank you.
It's so difficult to like force my brain